Hello all. Today we are solving LeetCode problem number 3212, count submatrices with equal frequency of x and y. So we are given a 2D character matrix named grid, where grid of ij is either x, y, or dot. Return the number of submatrices that contain grid of 0 0, which is the first element. So this should be from the top submatrices, so which means it should include the top leftmost element, which is grid of 0 0, and an equal frequency of x and y, which means count of x is equal to count of y in submatrices, and at least one x. So which means if there is no x and no 0, which is 0 and 0, then it is not a valid one actually, because you may have dot has the left topmost value. In that case, both x and x value is 0. So also y value is also 0. So in this case it is not a valid one. So this is just a edge case. So this is the requirement. These three conditions are the requirement to be a valid submatrix, and we have to count how many valid submatrices exist in a given grid. So this problem is very similar to the yesterday's problem, where we count the sum, and based on that we use a k value, and if the sum is less than or equal to k, then it is a valid one. But in this case it should satisfy all these three conditions to be a valid submatrix. So that is the one and only difference here. And other than that, each and every approach, the approach which we solve the problem, and the idea which we use to solve the problem is very similar. So now let us understand the problem. So this is the given matrix complete grid. So if we have to see from top left as the element, so if we are considering this particular uh, submatrix, because submatrix can be a rectangle or a square, right? So first we will start with this only, this x. So here this condition is satisfied, and this is also satisfied because at least one exists, but frequency of x and y is not same, so this is not a valid subarray, submatrix. So now if you check this one, we have this condition satisfied, the frequency is same, 1 and 1, and at least 1x. So this is verified, and hence you add result equal to 1. So now if you expand this again, you have this conditions verified, and frequency is same, and at least 1x. So now you increment the result to 2. So that is what they have mentioned here, this as a valid one. And when we are considering after this, if we consider this again, this satisfies the condition, so this becomes 3. And if we expand this square, here we can see 2y and 1x. So now frequency is not same, so this is not a valid. So again, if you expand this rectangle, similar, so there is no valid submatrix exist, so the result is equal to 3, and that is what we are returning as the output. So how do we solve the problem? We will be using the same prefix sum matrix concept, but in the previous problem we deal with sum, right, the sum of the submatrix. But now we have to deal with count of x, y, and the inclusion part is not required for this prefix matrix, but these two are the major thing. So we are having two prefix x and prefix y. So this count the number of x and number of y. So in terms we can represent as frequency. So we are here to, we use this prefix subarray or prefix matrix to count the frequency. So now based on this example, we have x y dot x y dot dot, right? So now we will have two prefix matrix. Let me draw them down. So done. This is for x and this is for y. So now we count the occurrence of x at this point position. It is 1, and we are here and looking back by using this previous count, which is 1 here, and in this position there is no x, it is only y, so the count remains 1 here, and we move to this position, again the count remains 1, and we are here, still the count remains 1. So now clearly for row 0 and column 0 it is pretty straightforward, but when it is coming to this position, we have to find a way to calculate the exact amount of number of frequency of x. So how do we do that? You may wonder that we have to add these two to get 2 here, but it is not how we have to solve, because we have to use the same exact approach which we used yesterday, because we know that at this position also you have only 1, so this should be 1. This is 2, adding this and this results in 2. How do we get 1? We have to subtract from this, so the same one, add left and add right and subtract from diagonal. So the same approach which we are using, so we are getting 1 here. So now looking at this position, you have 1 plus 1 is 2 and minus 1, it's 1 here. So this is the prefix matrix for x, and now for y. Here this is 0, and now this will be 1, the occurrence of y, and this will be 1, and now this will be 1 again, because we carry the same thing. So now this will be 1, and when it is coming to this position, 1 plus 1 minus 0 is 2, and now 2 plus 1 is 3, minus 1 is 2. So now this is the prefix matrix which we formed. So now what we have to do is we have to use the condition. So now look at this and verify the condition. You know the first condition is you have to have at least 1 x. So this should be true, and the frequency, which is nothing but the x prefix of I j, should be equal to y prefix of I j. So in this case you can say that the frequency is same. So if this is true and this is true, then you add result incremented by 1. So that is how you are going to solve this problem. So this is pretty much the idea to solve. So this is the approach which we are going to use, and time complexity for this is big O of n cross m. Since it is a grid, we are using the row and column to traverse, so that is all about this. And space complexity is big O of n cross m. We will be using 2 times n cross m, so because we are using two submatrices, prefix matrices for performing this operation, so hence this is the approach. With this idea, let us go ahead and code this up. So we start with n and m. So n is equal to length of grid, and m is equal to length of grid of 0. So let me copy the grid, and then oops, this should be equal to, and then we have to have the result assigned to 0 and two matrix basically. So 2 for x and y prefix sum calculation. So now you have x prefix is equal to this will be the nested the matrix which is 0 times m for I in range times n. So this should be the same initialized value for y prefix as well. So we change y prefix this x to y prefix name. So now this is done. So here we are going to have only the matrix iteration. We are not going to fill by the 0th column and 0th row. Instead of that, we can handle that by based on handling the index out of range by using conditions. So now for I in range till n times and for j in range m times. So now you have to fill in x prefix and y prefix. So is equal to oops, yeah. So now this is equal to this should be x prefix of ij. So that is where we are going to fill in. So we have to have the left value and the right value, the left top added and subtracted by the diagonal one. So in that case it is left will be x prefix. Oops, I think I didn't copy it. So x prefix of I minus 1 and j. So this is left if I is greater than 0, else it is 0, right? So I think this we should put this within a bracket to avoid confusion. So this should be added with x prefix of the top one, which we could find by I and j minus 1. So if here j is greater than 0, else 0. So now this should be subtracted with a diagonal where it is x prefix of I minus 1 and j minus 1. So now here both I and j should be greater than 0. So if I greater than 0 and j greater than 0, so else this should be 0. So now this part is done, and we forgot one more thing, which is to add the count, the grid place value, the based on the value which we are having in the grid. So we actually have x and y or dot, so we need to add the count, right? So if it is x, we add the count. So in that case this should be added with 1 if the grid of I and j is equal to x. This is capital X, yeah. So else this should be 0. So the same thing, but you have to replace with y prefix. Oops, this is x prefix, I think, yeah. So now you have y prefix. So change of names, y and yeah, you have the left, the top, okay, and this is subtracted by the diagonal, right, and then added. This should be y. So now you have these two handy. So now you have to go for the condition checking, which is nothing but indentation check. This is these three values actually. So here, if we are going to check if we have at least one x, right? So if that should be x of, I mean, the prefix value, right? And we can use this and to find the boolean value. So if it is true, which means it is greater than or equal to 1, so in that case x prefix of I and j, and then x prefix value should be equal to y prefix value, then you can increment the result by 1. So based on the discussion, x prefix value of I and j is equal to y prefix of ij. So now if it is true, both these two are true, you can increment the result by 1. So now that is it all about the code. So now we can return the result. So let me run it. There is an issue. So for I in range, there's a typo issue here. So let us check it now. And working, let me submit it, and there you go. Thank you.